Hello. In this video, I would like to address the learning target. I can find the solution set for a linear inequality system. This is our linear inequality system. 2x plus 3y is less than negative 3. Y minus 4x is greater than or equal to 2. When solving a linear inequality system, we're looking for a region on our coordinate plane of ordered pairs that will work for both of these. To do this, we're first going to find what we call our boundary lines. Our first boundary line will be the first inequality set equal instead of less than. This is an ax plus by equals c form, which we call standard form. When we have an equation in standard form, we can find the slope by taking the opposite of a over b, which in this case would be negative 2 over 3. And we can find the y-intercept by doing the c over b, which in this case would be negative 3 over 3, which equals negative 1. With this information, I can graph my boundary line. The y-intercept is 0, negative 1, which would be right here. Our slope is negative 2, 3. This is our rise over our run. Since our rise is negative 2, we would go down 2 and then over 3. That would be our run. We can see that this boundary line is going to be leaning left because the slope is negative, and it's a dotted boundary line because it is a less than sign. So now we have two regions, one above the boundary line and one below the boundary line. We have to make a determination on which of those regions to shade. I always suggest, as long as the point 0, 0 is not on the boundary line, that we can take 0, 0 and check to see if it holds true or false in the inequality statement. If we were to put 0 in here, we would have 0 plus 0 is less than negative 3. This is a false statement. Since 0, 0 did not work in our inequality, therefore the other side of the boundary line is where we would shade. All of these points are points that will work for our first inequality. Now we're going to look at our second inequality. Our second inequality has y minus 4x is greater than or equal to 2. We're going to start with our boundary line and say y minus 4x equals 2. It's quite obvious that if I add 4x to both sides, then I have y equals 2 plus 4x. This is in slope-intercept form. We call this slope-intercept form. In slope-intercept form, the slope would be 4 over 1, and the y-intercept is 2, which represents 0, 2. So for our second line, we're going to go ahead and graph this line using the slope and y-intercept. Y-intercept of 2 with a slope of 4, up 4 and over 1. Because this does have an equal bar in the inequality, this will be a solid line. Zero, 0 is not on that boundary line. So we can go ahead and put 0, 0 into our original equation, inequality. 0 minus 0 is greater than 2. That is a false statement. So therefore, we're going to shade the top part. We'll notice that right here, we have the lines, the shaded region lines from the first and the second inequality overlapping. This would be my solution set. So what I'll do is I'll put a big S here, and I'm going to show that it is the area above the second line, and it's that area below the first line. Any point that I pick in here, for example, let's take negative 10, comma 0. If I were to take negative 10, comma 0, just as an example, and put it into my first inequality, we have a true statement. The same should happen if I do that with my second inequality. And we can see that that worked, and we have our correct region. This is how I can find a solution set for a linear inequality. I hope this video is helpful to you. Please bring questions to class, add this to your algebra journals, and have a great day.